Good afternoon, panelists, and to our dear chairwoman, Engineer Helen Grace Gonzalez. Good afternoon, ma'am. We're going to present wind-powered fast mobile charger mounted on a motorcycle, and here are the researchers together with our advisor, Engineer Raymond Gray Saldua. Chapter 1, Background of the Study. The researcher came up with the idea of creating a wind-powered mobile charger that would allow the user to charge their phone while on the go. Due to the high demand of courier services, customers' phones have become a source of information and location. For effective charging of phones compatibility, the device outputs two distinct wattages, which is the 5 watts and the 10 watts. The device ensures the user's safety while driving without obstructing their eyesight.
Statement of the problem that the researchers were able to generate is that what design parameters should be considered to develop the wind-powered fast mobile charger mounted on a motorcycle. Next is what development and implementation strategy should be utilized to ensure that this device works. Lastly, what evaluation parameters should we assess in order to measure the performance and acceptability of this device? Objectives of the study are to design a relatively cost-efficient, to develop with good quality equipment, and to evaluate parameters to assess in measuring the performance and acceptability of the wind-powered fast mobile charger mounted on a motorcycle. So, the significance of this study of this research is that it will enable the existing wind-powered mobile charger to be transformed into a faster, more cost-effective, and more compact wind-powered mobile charger. So the conceptual framework is as shows. And then the scope and limitation of the study focuses on the design and development of a wind-powered fast mobile charger mounted on a motorcycle, with all materials readily available in Cagayan de Oro City, and if not, in the Philippines. That's all.
Okay, so for chapter 2, review of related literature. Wind turbines generate electricity by harnessing the wind, which is a clean, free, and widely available renewable energy source. Wind contributed to a reduction in the consumption of fossil fuels. Creating portable wind turbine is one strategy to encourage sustainable energy by being able to use wind energy effectively. The following are the related literatures that are studied for the development of the project model. Number 1, a non-conventional energy-based mobile charger towards green computing. Number 2, the Z5 Charge, a wind-powered USB charger. Number 3, development of wind-powered mobile charger. Number 4, wind turbine mounted on a motorcycle for portable charger. Number 5, mechanical and electrical mobile charger.
For the methodology, we have here our prototype design. At the left picture, we consider propeller, DC motor, components, and the attachment that will be used to attach the device on the motorcycle. At the right picture, we can see the back part of the device. It has the LCD, two switches, one for the DC booster of the Arduino that is connected to the LCD, and one for the whole device so the user would need to detach his or her phone after charging. And two USB ports which will have an output of 5 watts and 10 watts that can support a variety of phones. The components comprises of DC motor, propeller, Arduino, supercapacitor, DC-DC back converter, DC booster, diode, voltage sensor, LCD, and switches. And this is the proposed circuit diagram of the wind-powered fast mobile charger mounted on a motorcycle.
Next is the development. The integration of design elements is carried out in accordance with the system block diagram. The procedure is as follows. Wind blow during travel is the input. The propeller will start the motor, DC motor, microcontroller or Arduino, and supercapacitor. In this part, I will discuss further the procedure by using this flow diagram of wind-powered fast mobile charger mounted on motorcycle. When the wind blows during travel, the propeller will start the motor, which is coupled to DC motor, and generate power with an output of roughly 5 volts. The microcontroller will receive power as indicated by voltage indicator, which display the exact amount of voltage load through LCD. When the RPM is in maximum, the DC motor produces electrical energy, which charges the supercapacitor. Meanwhile, the diode ensures that electrical energy flow in one direction only. Moving on to the decision box, if the supercapacitor is fully charged, it is now ready to discharge. If it's not fully charged, it continues charging until it reaches its maximum capacity and then it stops charging. The supercapacitor was chosen as a storage unit because it is ability to charge quickly and discharge gradually, unlike an other storage unit. Because of limitation of wind blow, the researcher provide a supercapacitor to store electricity while the user is at rest. The Arduino and supercapacitor work together to rectify and regulate current flow, preventing overload and short circuit and ensuring that the system achieves the desired performance. Next is the implementation. The researcher will conduct a performance test to monitor the functionality of wind-powered fast mobile charger mounted on motorcycle. In order to determine its efficiency, the researcher will evaluate the wind input of each motorcycle speed to determine the exact output when traveling fast or slow. The researcher must identify the factors that can influence the system's power output, such as changing wind direction while driving. The researcher must troubleshoot after testing and detecting system faults. To avoid output problems, the device must be properly mounted to the motorcycle. The researcher controls the flow of power via a microprocessor, which allows the device to have a constant electricity flow. And next is the evaluation. Following the design and development of wind-powered fast mobile charger, the researcher carry out the necessary experimental setup to evaluate the prototype and the structures. The device design, efficiency, and the usefulness will be assessed. The wind power fast mobile charger will be tested at various motorcycle speed. The wind power fast mobile charger's behavior will be observed during the trial and troubleshooting of obtained results by choosing respondent, notably the food delivery riders. For the project evaluation, the researcher employ system random sampling, which is the most often used approach in statistics. A calculated number of respondents are given evaluation papers. The researcher employed a statistical tool with a scale method to evaluate the result. The Likert scale is used in questionnaire to assess the respondent's positive or negative response, as shown in the next slide. This is the Likert scale that we use. And that's all. Thank you.